Hey, this is where we get to be a little bit sad, a little bit teary face. It's your last video of the year. All right, so here we go. So I want to use binomial coefficients or binomial stuff in real life. And I'm going to take a little bit of time in these next two examples because, believe it or not, over half of your homework is actually on this stuff here, and there's only two examples. So I'm going to go through this a little bit slower, okay? So this example here says, hey, during a player's turn on a certain board game, players must spin a spinner. We've all done that before, right? The four possible colors the spinner can land on are green, blue, red, or yellow. If the probability for all four colors is equal, what's the probability of landing on green 5 times out of 10? So let me give you some background information. This is really not too difficult. So I'm going to define a couple of variables real fast. I'm going to say S is equal to the probability of success. And F, you guessed it, is the probability of failure. Okay. With that being said, oh, and then the last thing it is doing is, N, total number of times. And let's see here. Ooh. Successful with a little n under that. That's the total number of successes. So you need 4 numbers. Okay. Ready? Ooh, no, I just thought of one more. This is like this one. Fn. Number of fails. Alright, here we go. That's everything. So, once I define all those things, what I'm going to use as my little handy-dandy trick is I'm going to say, you know what? How many total spins are there in this, or total number of successes? I'm going to figure that as Sn. Choose the number of successes, not Sn. N. That's my total number of things I'm doing. And I'm going to choose my successful times because you know why? That's successful times. Why am I doing this? Okay. Because this is telling me, I'll get to that in a second. This right here, and then I want to multiply this by my probability of success raised to the power of S sub n, the total number of successes. Okay. And this over here, F raised to the Fn. Fn is the number of fails, F is the probability of failure. So why do I do all this? Okay, so when I do this example, I'm going to do this example here. So in this example, my total number of spins is 10. My successful times I want to land on green is 5. I plug in here S sub n, and so S, so what's the probability of success for S? What's my probability of success? Well, I'm only going to land on green one time as part of 4 of them, right? So being successful means, in this particular situation, I get a green. So getting a green is only a 1 out of 4 chance. Raised to, how many successful times do I need? Oh, 5. And then F is the failure. So that means, what does it mean to be a failure in this example? It means that I land on one of the 3 of the 4 other colors. So that means my probability of a failure is 3/4. And again, I'm going to raise that to 5. Realistically, so what's this over here? What does this have to do with anything? These two tell me the probability that what's going to happen one time, in one type of way. For instance, let's say I get all 5 of my greens first and then something else later. But then there's also what happens if I 4 greens first, get something else, and then get a green again. All those different combinations. There's a lot of them. In fact, there's 252 of them. When I multiply this all out, okay, what this is going to give me is 0.05839. Okay, that's the probability But what's that mean? Translate to percent-wise, you can even say that means 5.8% of the time I will get 5 greens exactly. I will get exactly 5 greens. Okay. Whew. It's a little bit of a lot. Hopefully it's not too bad. Okay. So let's go take a look at this next one. This one here says, hey, I got a fair coin. It's flipped 10 times. Find the probability of getting 3 tails. So again, let's set all this up. You set up N, S, F, SN, SF. Not SF. FN. Okay. So how N? What's the number of times I'm doing something? 10. 10 times I'm flipping something in the air. S, what's my probability of success? So they want 3 tails. Well, what's the chance of getting a tail? Oh, just 1/2. Okay. Fail. What's the probability of getting a fail? Well, again, not getting a tail means I get a head. So there's only another one. So my probability of failure is also 1/2. And they want exactly 3 tails. So what is my success like? Okay, number of successes. My number of successes is 3. And then finally, my number of fails. How many fails am I going to get? Well, if that's the case, I'm going to get 7. All right. So then what do I do from here? Well, from here, I just set it up, right? I just do what I said. It's 10 things. I want to choose 3 of them for my success. I'm going to do my probability of success is 1/2, and that's going to happen 3 times. My probability of fail is also 1/2, and that's going to happen 7 times. Go beep, boop, 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 beep. Put that in my calculator. I get 0.117188. And so what does that mean? That means that this will happen 11.718% of the time, where I will get exactly 3 tails. It doesn't seem like that big of a deal, or that much, right? Only 3. Okay. The problem is that these are only 2 examples that the book gives us. The problem is that there are more ways to answer a question. So I'm going to ask you to just listen for a little bit. I'm going to ask you to write some notes off to the side. So one of the ways I can change this one is, instead of saying exactly, I can change the words to say at least. Okay? At least 3 tails. What does that mean? That means it's okay for me to have 3 tails. It's okay for me to have 4 tails. It's okay for 5, 6, 7, 8, 9, all the way up to 10 tails. So what does that mean? That means the best way to handle this one is to do this. So if you see the word at least, one is make probability table. How do you make a probability table? Here's one right over here. It's already pre-done, but there was a little bit of work to get into this. Okay? So first thing you need to know is, hey, look, here, this is the one we just did where we get exactly 3 tails. Here it is, 11.7188% right there. So remember, this one was that whole 10, choose 3, business, right? And then 1/2 cubed, 1/2 to the 7th. This one down here is, right, 10, choose 7. 1/2 to the 7th power times 1/2 to the 3rd power. All right, and so that's how you build a table. It's like doing it a lot. Now, I know it's a little bit tedious, okay, but again, it's not difficult. So I made a probability table. Okay, step 2, add up all probability, see if it equals 1. If you did this table correctly and you didn't do any rounding whatsoever, okay, and you add up all these probabilities, I add all that up, this would equal 1. That means there's a 100% chance that anything's going to happen. That's how you check to see if you did it right. Now, you don't have to do step 2. I highly recommend it, though. And finally, number 3, okay, add up success only. What does that mean? In this particular case where I asked to find at least 3 tails, that means I'm taking all of this, 3 through 10, right there, and I'm adding it up. Again, I put that in my happy calculator and go beep, boop, 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 beep. And it gives me 0.94. 33, I believe. So what does that tell me? That tells me that 94.33% of the time I will have at least 3 tails. Rest of the time, I won't. So it's a pretty good shot. It's a pretty good shot that you will have at least 3 tails. Okay? All right. I needed to tell you that one. You need to be able to do this. My idea is, if you haven't done so already, write these 3 steps down off to the side someplace, because you're going to need them. Okay? All right. Next one. All right, binomial concept, key concept, binomial theorem. Hey, here's the big binomial theorem we've been talking about the whole time, expanding all these, a plus b to the n. Wait, I thought we got rid of all that. Okay, well, before we expanded them with Pascal's triangle, there are other ones that we would expand that are bigger than what a Pascal triangle would be, or use, that we could use. Okay, so I'm only going to do examples A and B. I will not do C, so keep this down. Okay, so use the binomial theorem. So instead of using Pascal's triangle, the binomial says, hey, instead of grabbing that, we use this here. Hey, there's our power. That's what we're choosing from. 3, choose 0. I grab the A part, 2t, raise that to the 3rd power. Grab the 3u, raise it to the 0 power. Plus 3, choose 1, 2t squared, 3u to the 1st, plus 3, choose 2, 2t to the 1st, 3u to the squared, plus 3, choose 3, 2t to the 0, 3u cubed. And I write everything down. I take all my coefficients, right? So I would go into my calculator, do 3, choose 0. Hopefully you know that that's 1. Anything choose 0 is 1. Okay. 2 cubed is 8. T cubed is t cubed. So I've got 8t cubed because all this is just a big giant 1. Plus 3, choose 1. It's 3, just so you know, 3, anything choose 1 will be that anything. So 2 squared is 4 times 3 times 3 gets me 36. It's 4 times 3 times 3, yep, 36. T squared u. And again, 3, choose 2, also 3. 3 squared is 9 times 2. So 9 times 2 times 3 is 54. T u squared plus, finally, last but not least, 3 to 3. 3 choose 3. Again, 1. Anything choose anything. The same anything gets me 1. And t squared is 1. 3, that'd be 27 u cubed. There's my answer. Boom. In fact, you know what? I'm just going to show you the last thing. Make sure that you guys remember this little fact. And that is, this is going to be exactly the same for this one here, except remember when you start this off, right, you have 4, choose 0, a to the 4th, okay, 2b negative 2b to the 0, right? Plus, and I'll do one more. 4 choose 1, a cubed negative 2b to the first. Okay, dot, 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 plus I'm going to keep going. And then when we do this, we'd have to be careful in seeing that, okay, that this one here, hey, it's raised to the first power. Negative 2 to the first is negative 2. So when I do this, it's really going to be minus 8 a cubed b. Why 8? Because 4 choose 1 is 4 times the negative 2, negative 8. Plus dot, 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 dot. And you keep going. As promised, about 15 minutes or 16 minutes. Take care. See you guys tomorrow. Congratulations, you guys got done.